Hi guys, Magan here, and I'm going to talk a little bit about Vide and Vectorblade and programming, and I don't know really what I'm going to talk about. Um, this is probably not very interesting for people who do not program backtracks, so no worries. You do not miss anything if you do not watch this. It's just perhaps if you do program backtracks and use Vide, perhaps I can show you some tricks. Or if you are interested in the inner workings of Vectorblade or something like that, then you can keep watching. Otherwise, you might have something else to do, I guess. Anyway, let's start. Let's look at the editor Vide, and here we got Vectorblade, the current project of mine. I just wanted to show how I, structured my source code and what I've done and how much code it is and how much data it is, because I got some of these questions and I haven't planned this video. I have no navigation path drawn out before me. I'm just going to talk and look at the source. So anyway, this is the project. Here you see all the files that Vectorblade consists of. I'll scroll through them. You see there are quite lots of files, and there are two main files. The way multi-bank Vectrex cartridges work is that you have actually two main programs. Each program is 32Ks, and you switch between them whenever you want. So there's a main bank 1, I call it, and a main bank 0. This is alphabetically sorted. Main bank 0 here and main bank 1 here. You also see the associated bin files that are generated when I compile, and these two bin files that are generated are concatenated to a 65 or 64K cartridge and then shuffled to the Vecfever or wherever I want it in an EPROM or whatever. The main cartridge or the main bin file, the one that is loaded first from the Vectrex, is always bank 1. And so this is, in my thought anyway, my main program, and bank 0 is my secondary main bank, if you so want. So many defines that I did are actually in front of bank 1. Here you see use PB6. If that is defined, then all the savings is enabled. Default start money, even if it's written wrong. 0, then I can configure how much damage the laser does, if you want to start with the shop or not. If auto fire is enabled, I can stop enemies from shooting if I switch this on. Undying, this is, I'm invincible, the player is invincible. No attack patterns, this is when I do not want enemies to attack me. No wobble, wobble is that what I call the waiting positions of the enemies if they do not move. This is what I call wobble, why ever. I've got an option also to keep the enemies undying, show coordinates, if I want Scoopies right from the start, if I do not want bugs to move, if I want blinking Scoopy fire. This is a test I did when the Scoopy fire is only drawn every other Vectrex round. It's a little bit flickery, I don't like it. It saves a couple of cycles, but yeah. Scoopies don't die. Hey, I got that. I didn't remember that I got this one. I actually looked for it the other day and it didn't find it, but it's the last one here. Then I got some comments what I want to do next and so on. And here's a bank actually starts off at org 0. I've got a couple of defines that I always include. They are in the special case that I have two main banks. In both banks have the same include files. In both banks one, this is more or less the header of everything, all defines definitions of RAM locations and so on. And I've got also in both banks two, this is the last file I include. Actually, I reserved a space of memory from 7,000 7A00 or something like that, where the memory or the ROM in both main bin files is exactly the same. This is mainly used for bank switching or handing over information from one bank to the other. And well, this is needed to have some space where the code in both binary files is actually exactly the same. Otherwise bank switching would not work and you would end up I don't know, crashing all over the code. So this is a start. I've got a header here. I'm just going to look at it in this header. Double clicking switches to the header. Yeah, there are many defines are made. Again, start with how many shots the game should start, with what kind of shot. One is a single shot, 6 is a laser, and everything between well, is in between. The fighter speed, the shot speed starts at 500. It's more or less the middle. It can go up to 1000, so you can gather 10 speed ups for both. Well, I do not actually explain everything here. You see the shot radius for the different kind of shots, which kind of level types I've got: normal, kamikaze, biggie, bonus, boss 1 to 4, and if a level can have a shop after, a warp after, and so on. For the queen, I've got some swarm definitions here. The rectangle where the swarm is keeping itself or is moving towards. The hit points of the bosses is defined here: 100, 200, 200 again, and 380. Sinister has got the most hit points. I'll probably keep it that. Then the macro definitions, usual Vectrex definitions from the Bruce Tomlin BIOS disassembly. I'll still use them. And then I've got all my structure defines. There is a swarm enemy, exploding enemy swarm, then the normal enemy struct, which is well, really confusing struct by now. Actually, it consists of 21 bytes, but many locations, depending on what kind of enemy it is, have double or quadruple meanings. Every 0 you see here is actually a secondary meaning for the byte that follows, where a 1 or a 2 stands. So the normal definition is the pattern definition, but it also serves as a sub-pattern definition and also as an animation definition, depending on what kind of enemy it is, and so forth. I'm not going to explain that all. Then exploding enemy structures, it's actually also 21 bytes, has to be exactly as long because it's just another enemy, but it doesn't have as much data. But I named it differently so I can easily access the data. Then there's an enemy struct repel. This is if I get Scoopies and have still the collector switched on, then the enemies get repelled and swoop all over the screen. This is a special structure. Then I've got shot structures, which again, this is a main structure, and there are different shots. There's a missile shot structure, and I think somewhere there's another one. A bonus structure, star structure. It's similar to the release stars. There are 4 stars drawn with one star element, atom, don't know how you call it. Then there are player shots, different player shots. Here's a laser player shot. Then there's a level definition and many things for level definitions. I've written about that at someplace else on the blog. Then these are enemy definitions. Are they easy, hard, hardest? Are they blockers? What kind of special features do they have? I think the type debris bomber I haven't got in the Alpha 5 version yet. It's a feature an enemy can have. If you shoot it, it can drop debris onto the player, and the player has to, well, step aside, otherwise it's hit by the debris and, well, death. Again, what's this? Enemy definition? What is it? This is not the enemy definition of the moving objects. This is the enemy definition, how they are defined in the ROM place, where, well, the actually enemies are defined, and so on. High score definition structure. Okay, here all the structures are defined, and now I've got different RAM layouts. RAM layout static. This is the RAM that is, well, what the name says, is static. For every part of my program, these RAM locations are always the same. But there are different RAM locations depending on where in the game you are. If you are in the title, if you are in the Dodger, this is the minefield thing. If you are in game, and I think there are a couple of other. I haven't got everything in the include, but the same RAM locations have quite a lot of different meanings depending in what section of the program you actually are. Short switch into the RAM. This is all the stuff you usually need here. The SFX pointers for some sound, joystick stuff, and returns from my object-oriented or stack-oriented object handling, high score stuff. Well, you do not need that everywhere, but actually this is also used as a buffer for some string conversions. The player positions, you often need that. Then these are all the structure definitions for the enemies. This is the enemy list, player shot list, bonus list, star list. These are the stack lists that I in-game, well, all the data is kept, and which I've worked through in the main loop of the game, and so on. There are many definitions here, and well, so on. These are different RAM locations here for the bosses. Boss 1 got this location. It starts at boss fight, and then the boss 2 also starts at boss fight, and boss 3 also starts at boss fight. And I could probably have thought of names which fit all boss fights, and I did not have to name all RAM locations, but actually I kind of like it. So if I look at the boss 3 code, I know exactly boss 3 mouth animation counter. Well, this is the variable for that, and I do not have to bother. Is it some temp 1 or temp 2 or boss temp 1 or whatever? I exactly call it by the name and know what it is. So each boss has its own RAM locations for all variables, and so forth. This is the beginning. Then there's a Vectorblade header file, and well, in the beginning, you first in it. This is all the stuff you do right at first when the cartridge starts off. This is looking if there is or what kind of devices are connected. Is there a Vectorblade card, or is there a DS2431? If so, I remember, and in the future I can save high scores and options, which I do in the future of the program running, and so forth. Then I jump at the finish to bank 0. In bank 0, the actual title screen is displayed, and if in the title screen button 1 is pressed, then the game commences. And again, we jump to, I think, main 1.1. And here the actual game starts off. This is a init game. Now if we should start with the shop, then the shop is started. If not, well, then not. If I start with scoopies, then the scoopies are initialized for the first start, and if not, then not. And this is the actual main loop, or the start of the main loop, main 1, main 12. This is the main loop, starts here. This is a game loop. Different things are done here. Here's actually, I do still use Vide recall. In the final version I will not use Vide recall anymore, but for now it's most easy for Tracky if I still use Vide recall. I will replace it with a macro my Vide recall, which is actually I don't know, nearly 1,000 cycles faster than the Vide recall. Don't nail me on that. It's only 500 cycles, but it's way faster to do an own Vide recall if you know what to do. But for now, for all the measurement, I use Vide recall, and well, that's fine with that. So then the actual main loop starts off. I look in which kind of game phase I am. There are two game phases: game phase intro and game phase not intro. I think it's called game. I don't know. If you mouse middle press double click, you go to the definition, and here I see intro and in-game. These are the two definitions. You can go back with the navigation button where you were, and well. And okay, if I'm in the intro phase, then I call do intro, and do intro actually in this phase all the enemies are introduced to the game via introduction patterns, and this is where all the bugs or enemies well, enter. If the game phase intro is finished, all bugs that will appear are in game. Then I skip the do intro and go, well, directly to the main loop. I do not have to check every game ROM if there's any more intros if the game phase is done. So this is that. Nonetheless, even out of the intro, new enemies can spawn, and these are only bug enemies that can spawn. This is handled in this section over here. I think at most 3 bugs at the moment can appear, and the bugs only appear if the certain amount of enemies is already dead. This is, well, because I'm cycle obsessed, and I think one big bug takes as many cycles as 3 or 4 enemies or something like that. So I draw the first bug appears if at least I think 4 or 5 enemies are dead. So I can keep up with a cycle count with 50 Hertz game speed, and well, it's a feature, it's not a bug. Anyway, all this code here introduces a bug, and then I display the score. This is what you see. I start the game, then I can show you what I mean right next to it. It's compiling now, takes, even on my fast computer, quite a bit, 2 bangs. So I can pause it and I don't die. This is a score here. It's displayed just with this one function call, and if ever some bonus or something wants to display some message, then a short macro display message it's called, and all variables are set, and this scrolls out and scrolls in, and I do not have to bother anywhere else with it. So this display score handles everything this little darling above here does. Then I display the static bonuses. Static bonuses are the extras that you can collect, which will appear up here. The extra bonus, which gives you an additional level of shot. Calibration, I start off with here. The next thing that is drawn is a fighter. In this code here, the fighter is positioned. This is within the moving of this little integration cursor, if you want to call it. Here I check several things that must be done. I spawn bullets if the player actually press the button. The button handling on the other side is done in bank 0. I'll come to that later. I check if the player was hit. If so, then I jump to dying. And this thing here, subroutine draw fighter, this does everything fighter drawing. That used to be a macro. I had it in here, but actually the fighter is drawn in several different main loops. And I had this macro in every game loop, and it saved me, I don't know, 2 or 3k that I just did a subroutine. It costs, I don't know, 10 cycles or whatever to call a subroutine and return from it, but well, I saved some Ks, so well, I had to live with it. It's always the division between memory and speed, and well, some thought of death, you have to die. Anyway, within this draw fighter, this fighter is drawn, and if the fighter collected any bonus, a shield or something like that, this is also handled within the draw fighter. Then I jump to bank 0. Do main bank 0. I show you how this is done. I call actually this jump, and at the end of this bank 0 jump, another jump is done to bonus done. This has historical reasons, which I'm not going to explain right now, but anyway, after this is actually a subroutine call which returns to here, but it's disguised as a jump. Do main routine bank 0, double click on it, then I go to in both banks. You see that? This little code here switches to bank 0, and this code here jumps to the game loop part 0 underscore m. This is the actual game loop part which I'm jumping to. This weird little code, if current bank like 1, if current bank like 0 equals 0. It probably can be done much more efficient, and I think I also know how I would do it now, but this code actually is, well, pretty old, and it works, and working old code, well, code is, well, I'm not really good at working old code, which could be done better. Never change a running system. Anyway, the gist of the thing is, since this code lies in both banks, and it has to be exactly the same size for both banks, otherwise it does not work. I do here just a jump to anywhere. There could be 5,000 or something. This is actually non-used space, this jump, but it has to be exactly as long as a jump in bank 0. Otherwise, the next subroutines and routines in general which follow wouldn't have the same memory address for both banks. So this in both banks is included within both banks, and in bank 1 I've got this current bank definition equals 1, and in bank 0 the current bank definition equals 0. So I come here with my jump from bank 1, switch to bank 0 and 0, and automatically this, well, jump appears magically in the code, and the code well, continues there. Okay, I jump there. So now I'm in main bank 0, my bank 0 part game loop. The reason I splitted the main game loop between bank 1 and bank 0 is because the game uses huge amounts of data, and one of the features which uses extensive data are the bonus drops. There are 20 or so bonuses. Each bonus rotates with, I don't know, 8 or 9 or 10 or whatever vector lists, and 20 times 8 is 160, and every vector definition has, I don't know, let's say 15 vectors. Then we are at quite a large number, and each vector consists of, in its definition, of 4. Then we have a quite large number times 4, and I could not keep every data in bank 1, so I split my data to bank 0 and bank 1. In bank 1 actually all enemies are defined with their data and animations, and in bank 0 all bonuses are defined, all fonts are defined. So this is the split I had to do. Huge amount of data I cannot keep in one bank, so I have to switch between 2 banks. And this is originally the thought: bonus in bank 0, enemies in bank 1. Anyway, the first thing I do here is display the player shots. This also has to do with sizes, because the player shots, they are small. They are just one little vector, but it can be 1 vector, 2 vectors, 3 vectors, 4 vectors. The 4 vector shot, the 4 shot actually are 8 vectors, because there are some moves in there. Then the 4 shot also has the scoopies, which is vector size times 3. I actually do not draw vectors. The code for the shots is code. It's not data which is displayed via some vector list draw routine. The shots are displayed by code. One line is drawn after another with just code. So these are, what did I say? I don't know, 12 shots with 3 or 4 vectors each are drawn, and the code alone for the player shots is, again, I don't know, a few kilobytes. It's 2-3 kilobytes or something like that, because it's a huge huge collection of macros. Perhaps I will go into that later, but anyway, player shots are displayed in bank 0 because of that. It's actually an object list. I described it somewhere else, and I won't go into it. Sufficient to say, well, it's called here. Then the joystick is the joystick code is called. The get button code is called. I do not call it every round. I have odd and even rounds, and in odd rounds I get the button state, and in even rounds I get the state of the joystick. That is sufficient for fast enough movements. I have to check if the player is auto fire. If so, then, well, it fires automatically if the button is pressed. Otherwise, it just fires once when a button is pressed. Sound routines are also all in bank 0. So every sound that is played on every song that is played is bank 0 stuff. Then here you see the bonus stuff begins. If an enemy was destroyed somewhere, then this variable bonus spawn position is set. If not, it's 0. If it's not 0, then it's a position where the bonus should spawn, and this little darling spawns bonus. Actually, I think the randomation function is called, and if rand is in the appropriate value range, then the bonus is spawned, not always. It's, I think, 5 bonuses maximum that can be displayed at one given time. Actually, I could display a few more, but I haven't got the RAM left. That's all. Okay, then check if there's an explosion sound to be played. Well, if a enemy died, then these 2 pokes here just ensure that an SFX is played. And the last thing that is done is actually displaying the bonus list. And the bonus list automatically returns to bank 1, to this position, bonus done. This is why it's called bonus done. Then the stars, if there are any, are displayed. It's also a vector object list. Then the enemies are displayed, also an object list. This code here is quite new and I don't like it, but I haven't gotten any clue yet how I could do that any better. Actually, this is code for the laser. This is, you might have guessed, because it's laser enemy pointer. I thought the laser, as I implemented it before, was too strong, and I think once you got a laser you could play the game probably endlessly. And my thought is that I will do different difficulty levels, and in the easiest difficulty level the laser will stay as it is. In medium and hard and impossible levels, or whatever levels I do, the laser will not continuously hit all enemies. It will only hit enemies, the enemy which is lowest. And after that the laser is broken and cut off. And this is something that I did not anticipate from start, so this is extra code to handle that. And it's not as easy as it might sound, because all enemies that are present on screen are not sorted in any way. So I have to go through all enemies, look which enemy is lowest and is then hit via the laser. And then I have the position where I can cut off the laser, and only then I can go and hurt the enemy, because every other enemy above the enemy that actually got hit must not be hurt by the laser. And I twisted my thoughts around that, and this stupid code over here is actually what I came up with. And with this code additionally, and some codes well within the enemy, it does work, but it costs quite a few of cycles, these extra things, and I cannot hide them anywhere in any moves that I can think of, and they must be positioned exactly here. Anyway, and then the shots of the enemies are displayed. Again, another object list, and with this the main round ends. Again, we go again to main start. This is my game loop. From somewhere from here on, from the point where I start in bank 0, I am not allowed to use the stack anymore. Everything I do below this must be done without stack, meaning I cannot call any subroutines. This is because I use both stacks, the user stack and the the S stack. What's the non-user stack called? Don't know. Oh, U and S, I mean, are both used within these object routines. The actual object list is always called is always kept in the S stack, in the non-user stack, and every drawing is done via smart lists, and the smart lists use the user stack. So both stacks are continuously used by these object routines, and well, there are some code stretches where you really have to think around the corner if you do not have a stack. But well, it is okay. It's doable. Okay, this was one main round. I do not think I will go through all of the code. This is most boring for you, and my mouth will go dry. And this is just, well, one thought about the how I did my main loop. Perhaps I will go a little bit through the files. You see there are really many files over here. This is because I wanted to sort files and find things fast. I like finding things fast, because in such a huge code, well, you use most of your time looking for something that you wanted to use and can't find it anymore. For this, if you use Vide, here's some sort of contents for this file, main1. This is a user type which I usually use. So if I want to go to my init game, I just double click here, then I go to the routines init game. Is function, this as a comment is a denominator for the user type. You can display, well, all these different kind of labels, structures, whatever within this contents, but I usually only do user labels and macros. Macros probably I don't do either, because this is well, within range that I can process. If I display anything, then I'm lost again. So for every function that is worth mentioning, I just do a comment is function, and it appears in this contents here. So if I want to go at init warp, then I can just jump there and so on. With the files, it is sort of similar. All files are included from main1 or main0. All includes I do are, well, right in the beginning in both banks, or at the end. These are the only positions that I do includes, and this way I can find my includes really fast. So if I want to look at my code that I did for the boss 4, this is the Star Wars thing, I go to the include and can double click here. I'm right into the include file, or because I know it's boss, I could see look here at boss, and here I have two files, boss 4 code and boss 4. I didn't write data to it, but next to it, but this is actually the data for the boss. As you can see, these are all smart lists. Smart lists in general have a couple of data entries. These are this is a position that in some way has to be reached, drawn, or moved to, or whatever. And this is a function call that is used to achieve the positioning. And these calls are quite optimized and called from within the draw routine using the user stack. Yes, this is actually then the D register, and this is actually the P or PC, the program counter. And first thing it does is move to this position or draw to this position. So this is really fast. You can inspect the functions if you well, go to this pointer and middle double click again. Here we are in the file draw list. There is a file draw list 1 and draw list 2. This is for different scale factors. The functions are exactly the same. One set of function is called sm underscore something, and the other function is smb underscore something. This B originally stands for boss, and it denotes the boss sprite scale of 50. And if we go to the draw list not 2, this is here, you see exactly the same functions, but with a sprite scale of 5, or actually it's 9 inside, I think. These are the functions. So if you have any kind of list here, these are calls to the functions in this draw list include files. Here you see they are actually the positioning continuous. This is yes, the via calls, and they all end with additional knobs. Not for the sprite scale 5 or sprite scale 9, there are no additional knobs. This macro here handles the count of knobs that have to be inserted, and all of these functions end with pull of the user stack for register A, B, PC, so it continues. So actually what this definition of a vector object is a really long user stack pointer, and it's pulled register D and register program counter, one after another, all these vector datas called functions from this include file here. There are quite many functions. This is because of the optimization. The Vecchi, the vector drawing tool, recognizes all kinds of special cases within a drawing. So it recognizes if the y coordinate is equal to the x coordinate, or is the y coordinate from the next vector to be drawn is the same as the x coordinate from the last vector, and so on. And so many special cases are considered, and thus these little functions are all optimized for the, well, for the thing you really want to draw. Yeah, these are the smart lists. Perhaps I can show you a little interlude when I go to Vecchi, the vector tool, how I handle stuff within Vecchi. It might be interesting. I don't know if I showed it anywhere before. Actually, Vecchi is quite a mighty tool, and I'm probably the only one who really uses it to all its extents. But I'm just going to show you what you can do with it, or what I did while I edited all the vector lists for Vectorblade. This Death Star thing is my first draw, which I showed on my blog before. This actually consists of 265 vectors. You can draw these in 50 Hertz, but only just. In game it's not possible. It's just far too many vectors. What I did is have this gigantic vector list, and I reduced it to another vector list. Can I open a second Vecchi? I think I can. This is a second instance of Vecchi. The final product I reduced it to is Little Death Star Optimized. This is the one. One moment. I will show you what I do just now later, but for now this is the final version that you see in game. So it's well, it's not nearly the same. It has quite a reduced vector count. It's now 143, so more than 100 vectors less than this Death Star. What I actually did is edit this thingy here and reduced its vectors to, well, to the instance you see here. How did I do that, the reduce? There's no automatic reduction I implemented, but it's quite easy if you can use Vecchi. Oops, oh, I didn't want to do that. Take that back. So I'm going into it, and one thing that you can reduce mightily is this. I don't know what it is. It's a gigantic weapon or something like that. What I did is actually put all these together into one triangle. 4 of these thingies into one triangle. How did I do that? I'm marking the vectors which I want to. I do not want anymore, and right mouse click, delete selected. Well, that was not so difficult. I switch on continuous mode, and now I can connect these leftover vectors. If I go to, what is it, point? I think point. I'm scrolling it, getting a little bit nearer. Mark this one with press shift, shift pressed, join selected here. Now I join these vectors, and it's getting more triangular. something like this. Now I still have a continuous triangle, more or less, but the vectors are connected again. But actually these points, I don't want them also. So what I do now, I switch, now I'm in point, I'm going to vector, I mark these two vectors and go to remove middle point. I do that for all the vectors, and now I've got a complete triangle for the from the stuff from the 4 objects I had before. I did this for all these things. It's a little bit boring job, but it actually can be done in a few minutes. And if you have to start anew, it's way more work. I did this with well, many things here till, well, I reduced it about 100 vectors, and above here I put them together also, I think. Yeah, this is how I reduced the gigantic star to the star you saw before. All these commands you can use. Often I use actually this shortcut too: disconnect all, remove all vectors, remove all doubles, remove I doubles, and remove dots. So these are actually now only vectors. There are no move vectors inside this thing. And if you press EZ to all, historic reasons why it's named like that, then you actually, it looks like it increased the vector count now to 306, but this includes all possible move vectors, and actually the whole Death Star is now drawn in one go with move vectors in between. Well, you still can't draw it like that, then it will wobble like hell because it just takes too much time to be drawn. What I do then is actually make a scenario of it, and a scenario is drawn in different stages with vector resets in between. You can well, do your scenarios however you want. What I actually did was something like that. Well, we are on point. It should be in vector. I take some of these vectors that are drawn. I don't want to grab that. Just as an example, I take these vectors here and I delete non-selected. Now I've got only these vectors. Add to the current. Then this is one part of my scenario. Then I take the steps back I just did, and you see the whole Death Star is here, and now I've delete selected. Now these both images, so to say, complement each other. You can do that in different steps. Then you have different steps of your scenario depending on how many vectors you want. I can add the current again, and these both together, these animations or scenario parts, are again the complete Death Star. I can switch between these two here. I can edit them now. Now this part here has 169 vectors and this part here is 137. These are still too many vectors to be displayed in one go, so you should go for something like maximum, I don't know, 60 vectors or something like that. If you want to just display them with smart lists and a scale factor of 50, then this is okay. Now we've got two separate vector lists down here. If you ever want to join them again, you can do that also. Let's imagine this one here is empty. You go to one of the vector lists down here, and here you have got this button edit on select. So every time, if it's checked, every time you switch between these vector lists here, the one is edited. If you want to join these two, you have to switch this off. So if I now switch to the Death Star, it's not edited right away, but now you can use the join button over here, and the two vector lists are joined. So you can recreate your original vector list if you ever want to do that. This is a combination of buttons that I use sometimes that is not obvious, and I don't know if I actually documented it very well, but so you can join scenarios down here. This is how you can also use, if you want to do a vector text in one go, then you have all the letters down here, edit on select, and then you just select the letters you want and join them, so you can build a new vector list over here, complete the vector list. I'm going back to loading the Death Star Little. This is the original one I did and split up in scenarios. These are now 4 vector lists. This one has 30 vectors, this one has 24, this one has 34, and this one 28. So I chose something around 30 vectors for my display. If I display that now, I can go, if I want to use smart lists, I go to the smart list tab, export smart list, and say I want to have it runnable, so you can see it over here. Build a scenario list, and you can actually run it right away using a smart list. The code generated for smart list always has a calibration coming with it. Calibration is done via joystick up down, I think, or left right this time, and you have to calibrate it. If you do not want this calibration, you just have to remove the call to the calibration joystick. This is this code over here. This does all the calibration. Now you see the complete Death Star is displayed. I don't know, I think the calibration is not really good yet, something like that or so. And it's using 18,000 cycles. If I remember correctly, this is a non-optimized version. Let's just try and optimize that with easy to all. I think I didn't do that. I go through all these scenarios over here and just press easy to all and then apply. Then all the steps are applied to each of the scenarios. And now let's run it again. It's probably more vectors. If you look at the count here, here's over 40. But as I said before, this includes all the move vectors. If you do not include the move vectors right from the start, included in the vector list, the smart list routine, which generates the smart list generates its own move vectors, so it can be done correctly. And this is not so optimized as this version over here. So I think it will probably be faster. We are 18,700, about something like that. Did I build a new scenario? I don't know. Now I built it anew. I guess it is faster. Yes, it is faster. Now it's about 14,000. It's 4Ks, 4 kilocycles faster than the version before by just pressing an optimize button. Now the vectors are drawn in a correct order. The amount of move vectors necessary to draw the Death Star is reduced heavily. You didn't see it in the vector count here, because before the move vectors many times were not really present and had to be inserted later by the smart list itself. But this small button press over here just saved us about 4,000 cycles for the Death Star, which is quite impressive in my opinion. Anything else for Wacky? I don't know. Yeah, many small things that can be done. Perhaps one thing, if I can find the correct list, which I did, Death Stars, this one here. If you looked at the Death Star within the game, you will see that this weaponry thing rotates. I did this also with Wacky. This is the original rotation list, and just a few steps how I did that. Delete. I delete all these things over here. I started off with one triangle, And to have it in a regular way, the easiest thing you can do is mirror it. We've got somewhere some mirror capabilities over here. I put the complete vector list as it is now within my buffer. This is copy to buffer. Mirror it horizontally. Now I've got this one down here. And now I paste the buffer again. Now I've got already two of them. I copy them again to my buffer, select all vectors. Now I rotate them for, is it 90 degrees? Then I've got this one and paste it again. Oh, I didn't I paste everything? Select all. I've got select all and vectors. Okay. See, I didn't copy. I just selected them. Copy to buffer. Rotate by 90 degrees. Paste buffer. Now I've got four of them. I again paste them, and now I rotate by 45 degrees. I've got that and paste it again. Now I've got a complete circle, if you so want. And this thing I can rotate. This is what I did here. I think it's the z-axis that I did. 1, 2, 3, 4, 5, 6, 7, 8. Rotation, 8 steps. So that this one over here actually reaches exactly this one. So I just rotate by 45 degrees and then repeat all over. This is, I think, what I did. I clear the vector list down here and just do it. And let's see what happens if we play this. There's a little delay you see here. This is because the last generated rotation vector list is exactly the same as the first. This is always the case. Just have to remember that if I delete the last one, as did, now it rotates continuously, smoothly around a full circle, so to say. I'm going back to the circle. The Death Star over here, this is not a view directly from above. It's slightly rotated to the side because it's, well, it's not a frontal look. I also did that, I can't remember which one, I think around the X and Y axis for some particular angle. I rotated all these things by a certain angle, and now I've got the rotation which fits exactly into the Death Star. I'm going to delete the first vectors so you see how it actually looks when the Death Star is displayed. Here you see that. Did I delete one too many? There's a little jump in here somewhere. Probably didn't do it right, completely right, but this is actually the rotation which is used for the Death Star in game. Yeah, let's just do a step back again to the little Death Star optimized. This is the Death Star which is actually displayed in game. You can switch here between animation and scenario. The difference is that scenario is buggy and animation is not. Oh, why can't I see the scenario? It should display, if I switch to scenario, the complete vector list here. I don't know why it does it. If you switch to perhaps I should play. If I switch to animation, then this is taken as an animation, and if I switch to scenario, it should be display the correct thing above, which it does not, and I don't know why. It's a bug in Vide discovered. Okay. Anyway, what I really actually did is use this scenario, build scenario. I can do it as runnable. I did over here already. This should be the 14,000. Yes, this is exactly the one I showed you before. And this is actually 100% the vector list I use in game. I do a copy and paste from here. Only the scenario list. and copy it to my game and change the SM underscore to SMB underscore to take a higher scale factor. Yeah. This is just for smart list, how I use them, how you can edit them, how you can do scenarios, and you also can do animations. If you want to look at the source code in the editor, you can always, if you generated it as runnable, or if you didn't, you can press this button here, then the editor opens, and this is actually Vide with a code generated, and you also can run it directly from here if you want. It's if for some reason or another there's an error in here, it is not displayed. If you run it in Vide, yeah, Vide, it's the errors are displayed in the editor messages. So, okay, this was a short step to Vecchi. And this is the first Vecchi I opened. So, this was a little gone too far, I think. We were actually at the code that, or the contents of the directory. Well, as I said before, I named all these files so I can easily identify them. AFX player, this is everything that has to do with playing AFX. There are 3 channels, so there are 3 files. Arcos player, well, it's an Arcos player. Bonus.asm is a collection of all bonus related stuff, and it does includes also these includes are all data includes. There the vector lists for the actual bonuses are contained, and with bonus.asm, what does it do? I have to think about it. Initialize bonus. Oh yeah, this is the random generation of the bonus. There's the randomize macro here, and these are the values each bonus receives or has for it to appear. And for the fixed bonuses, I think these are the actual vector lists which are displayed above here. Okay, these are all the definitions for the bonuses. So the armor bonus, for example, looks like this. There's a complete bonus structure, if you want to call it. It contains first a pointer to the bonus animation, and this is a type, actually. I don't know what is it. It's 13 times 2 times 2 because it's a word pointer, and these are the actual animations. It has 9 steps and goes back again using the same steps. For the bonus stuff, I modified the smart lists again a little bit, because every bonus is surrounded by a circle, if you want to call it, or it's an 8-sided tangle, whatever. This actually draws for the armor. The first, 8 lines draws the armor, and I've got a special smart list function I programmed, move to D, and jump. And actually, what this does is jump to another smart list and continue drawing there, and it jumps to the smart list denoted by the next word pointer. So what this does is actually draw the armor bonus, that is a little shield thingy, and after drawing the armor bonus, directly jump to the next smart list and draw the bonus circle, and this is over here. This is the bonus circle. You have to be certain that the start point for the circle is always the same, but well, you have to define the list that way, and then it's okay. You can do that also for animations. You see the armor, the bonus rotates when it falls down, and the circle also rotates, and so every rotation step jumps to the corresponding circle animation step. And this alone saves, I don't know, 4 or 5 kilobytes for vector list. If each of the bonus had its own, had to draw an its own circle. That would be a huge amount of double data within this vector list. So this is one step I took that saved me, well, quite a lot of memory. Okay, these are all the bonuses. Then there's the boss code. I already showed you that. One little note for the boss code, for example, code 1. Here I did something because the bosses are also kept in bank 1 and bank 0. There is stuff I need in bank 1 and stuff I need in bank 0. Actually, all the graphics, all the vector lists for the bosses are also in my auxiliary bank 0. But all the fighting stuff, more or less, and the main loop goes on in bank 1. So this file over the boss code here actually contains both codes for the bank 0 and bank 1. And they are included from main bank 1 and main bank 0 also. And here you again see I've got an if clause right at the beginning. If current bank equals 1, then I've got all the boss fighting stuff, the initialization stuff, the main boss loop with collision detection and so on. And somewhere at some point there will be an else. Somewhere is an else. Here is the else. And from here on everything following is in bank 0. So these files contain actually two bank informations and are switched via if then else clause. Well, then I've got big bug definitions. This is nearly the same as the enemy definitions and calibrations. Dodger, this is actually the complete Mindstorm game I implemented. Here you have, well, not many functions, I think. I have these, looking for something specific which I do not find. Nope. Okay, anyway, this is a complete Mindstorm game. Then the draw lists, we already looked at them. Draw subs, there are some other drawing functions, and then the EEPROM functions. These are the enemy definitions. The enemies itself just contains include files for the enemy definitions themselves. As of now, these are the normal in-game enemies. Then these are the bugs. These are the sinister enemy definitions. The swarmer for the queen and enemy other. Which one is that? Ah, that is the one debris bomber I did, or at least the debris bomb. It's working all right, but I think I did not include it in Alpha 5 in any level, so you can't see that yet. Well, that's a surprise for the final game. Anyway, then this enemy shot call detections. These are macros which are called within the behavior routines of A, the enemies, or B, the bosses. Each boss has its own collision detection macro. Well, they are nearly the same. Just some offsets are different for the bosses. So, well, I could probably do them as a subroutine with some variable, but it's not really worth it. And then explosions, this is just a text file, so it seems. I think it can be deleted. Then I've got all the attack patterns, pattern definitions, and these are the levels or level definitions. As you can see, as of now they are level 1 to 24, then some bosses and some experiments over here. Yeah, then the pattern definitions again, other pattern definitions. This is the fighter data fonts. I've got game loop asm. What is that? It's empty. Oh, okay, don't know. High score. This is actually a copy and paste from the release high score thing. I haven't looked at any high score coding as of yet. It does work, but I don't like it, and it will change. Then in both banks, you already seen that. These are all the things that I have to do in both banks. In both banks too, we looked at the bank switching things. I have different bank switching functions which I can call. I can actually do a subroutine call to bank 0 or to bank 1, and I can a direct and indirect subroutine call, and I can do jumps which jump back to certain locations and so on. These are all bank switching things. Yeah. Then I've got objects. Messenger. Messenger is perhaps interesting. Messenger file includes everything that has to do with this score thing. I titulated it Messenger because it also can display messages. Well, yeah, this is all the code for that thing. Object, this has the general object things within it. Actually, this is quite more or less small file. The object itself does mainly include the introduction, the do intro, which was called from the main loop to introduce enemies with patterns. Then I've got different object files because I've got different object lists, and they are handled all a little bit differently. Object bonus includes every object file for object routine for bonus. Here you can see in the inventory, in the contents, new bonus objects can be created. Spawn bonus, which calls the new bonus, and after spawning it does something else. Then I've got different behaviors. Simple bonus behavior, falling bonus behavior. This is when it it falls down, and if the player caught the bonus, you have to react to it, increase shot speed or something like that. Remove bonus is called over here, and go home bonus behavior. This is for the letters when I caught them and they go to their static position. And actually all these object files here have more or less the same structure. The enemies have also new enemy object, spawn enemy object, destroy enemy object or remove enemy object, and then however many behavior routines for whatever they want to do. You can increase the size here a little bit so you can see them. This is the enemy explosion behavior, enemy simple behavior, enemy simple attack absolute behavior, clone behavior when these clones are happening, waiting position, single attack, intro pattern behavior, fly home behavior, delay behavior. This is when the enemy delays before coming displayed again. The repel behavior, the Scoopy behaviors. These are actually still enemies, but it's enemy controlled, player controlled behavior. And so on. These are all the behavior patterns that the enemies can have. Then same goes for enemy shots. They are player caught shot. This is when the player got hit. Remove, spawn, simple shot behavior. Then the missile behavior, shot at behavior. Then the letter thing from Sinistar. These every letter has a different behavior. This looks more complicated than it is. It actually is. Each letter starts with the pointer in the alphabet it represents, and then goes to a general sort of letter behavior, and this is a letter at player behavior, and this is actually the letter shot then. Swarm enemies are quite different because the enemies are displayed not with smart list this times. The swarm enemies, because there are so many, there are 30 of them, they are displayed completely different than any other vector list. They are completely drawn in code again, and this again is highly optimized code. Actually, this is, if you want it like that, the vector list for one swarm enemy. There is no vector list data anywhere. It's actually really code, and code generated with these macros. It's a init draw, which is here. It does the move to and actually switches the auxiliary control register to a different mode, and then displays each line directly. This little darling here displays one vector of the swarm, and I don't think you can get any faster displaying one vector than with 4 lines of code, which actually only does load some data, writes some data to port B. Well, actually there should be a couple of knobs in here, knob 2 or so, then the enemies would look perfect. But I really don't need and want them to look perfect. So the code actually draws too fast to actually draw nice vectors. This results in vectors being a little bit round and being a little bit distorted. But for the swarms, I accept that, and I call it a feature. It's not a bug. Perhaps I will insert 1 or 2 knobs. It looks slightly better, or different at least. But well, this is fast. Well, there are 4 animation steps for the swarmers, so 4 vector lists actually get drawn here. This again uses quite a bit of memory, but by now I've decided I'm going to waste a little bit of memory. Player shots, I mentioned these before. Player shots are handled within bank 0. Player shots actually are also macro generated. We go, for example, to the 4-player shot behavior. Here you see some well, some code, but the actual drawing is done in draw player 4 shot, and if there are scoopies, then you go to draw player scoop right or draw player scoop left, and these are all macros. I just show you one. The others are nearly the same. This is a draw player macro, draw player shot macro. First, it's a move to, and then the real drawing is done. It's in continue. There are no more moves. And go to that. Then I move 1 step to the half left. 1 step to the half left. It's actually this little code over here. It just pokes to the wire and 1 step to the left. Then, next, I load the player with the shot length. This is actually the Y length. Delay a few cycles in relation to the scale used. This is also funny again. I use different scales for the player shots depending on if they are scoopies or non-scoopies. And this delay cycle macro actually calculates the amount of delay I must do in order for the shots to still look like shots. Then I draw 1 vector down from the position I'm currently at. Drawing 1 vector down is actually exactly as drawing 1 vector up, because the difference is just the sign of the coordinates. And draw 1 vector up is again here this little code. Actually, it just stores the position information, loads the shift register with a certain value, and enables the timer, and then writes into the shift register. What you see here is actually some sort of a pattern. 1 shot does not enable the shift register and then disable the shift register, as you most of the time see. Actually, 1 vector of the shot is always a pattern. It starts off with 0 and ends with 0, so I do not have to worry if the shift register contains some random 1 or something like that, and I do not have to stop shifting at any point, because this last 0 here ensures that the shift register at after 16 or 18 or I don't know cycles is actually filled with a 0, and the ramp is filled with a 1. So it does not blank. Blank is filled with the 1, and it does not draw anymore. This 0 here ensures that the blank register at the end of the shifting phase is 1, so it is blanked. It's inverted. Well, this is one shot of the 4. Then I go one step to the left, draw down. This is my next shot. Then I go one right up, right up, also 2 steps to the right and 1 up, draw down again, move right up, draw down again. And now I've drawn 4 times. This is a 4 shot. This is 1 shot I actually drew on the screen. Go back again, and I'm finished with the player, and now I continue with the scoop. The cursor, or the integrators, if you want, is still at the same position as when I started, because actually the draw player shot always returns to the position where it started, so I have a fixed point, and then the scooper is drawn, if there is any scooper, right from that position. And after the right scooper finished, it's exactly at the same position again. So when you leave the draw player macro, and when you leave the draw scoop right macro, the position of the beam is exactly the same, exactly as Vectorblade can do. And from there on, if there's another scoopy, the rest of the 4 shot is displayed again with the macro, which looks more or less exactly the same, just steps to the left instead of the right, and is displayed on the other side for the next scoopy. So all shots for one player, including the scoopies, is drawn in one go with one macro. And this looks more complicated because the shots get reduced when they hit an enemy. This is a draw player 4 shot, but if one of the scoopies already hit a player, then the scoopy shot is not a 4 shot anymore, it's a 3 shot or a 2 shot or 1 shot. This is why there are more than 1 macros over here, and this is why a player 4 shot can also have a scoopy which does a player 3 shot, a 3 shot or a 2 shot. And for the left it's exactly the same. So this again multiplies the shots, or the possible shots I have to draw. Yeah, and this is why the shots actually are so huge in code, because each shot is drawn with macros, and there are so many possible variants to consider, and it didn't fit well into my bank 1, so I switched that to bank 0, to my auxiliary bank, and so all shots are displayed there. Yeah, this is where I was now. I don't know. Then object stars, well, this displays the stars. Player explosions, this is more or less the data, all data for the player explosions. I talked about that in another blog or a video. This is a copy and paste from there, more or less. I think I tweaked a little bit of code anywhere, but the player shots you just saw are all kept in player shot. These are all macro definitions. Then I've got these different RAM layouts as files. This is a RAM layout for the Dodger game, for example. The others I showed you before. Then I've got a file for all things that have to do with sound. This includes the AYFX player I showed you before, write to PSG macros, the YM sound generation, and all sound effects. And finally, I thought below here they were the music files, but I think I include them directly from main 0. Swarmer, this is the definition for the swarmers, which I told you before were not drawn using smart draw, but I've got a defined switch for if I ever want to do them, want to draw them as smart draws. This is quite a lot slower. At one stage I probably remove that define, but right now I can define draw as smart, and then the swarmers are drawn smart, and this file include file will work. These are the actual music files that I got from VTK. This is the title music. Vectorblade Asm. What might that be? This is actually the blade in the title screen. I think the title screen will actually be quite different in the future. Oh wait, why not now? I show you what I started doing for the title screen. I started within a different file. Hello? Okay. Last project stuff. Let me look at it. Vectorblade. There must be VB titled somewhere. No, it's not. I don't know why not. So just let's load it. Projects. VB title, and there is VB title project. This actually is what I used here. Last year I started to draw to begin a jump and run game, but I never really finished it, and I might go back to it because I really like the routines I programmed for it, and it's still kind of cool. I reused that to start a new title screen. This is just an idea I had, and I think I will follow it, but it's not finished yet. This is just an example what can be done. This is actually the tile display from before. I used some enemy tiles, and what I probably do for Vectorblade is write a gigantic Vectorblade here and scroll through it. This is actually smoothest scrolling with clipping done, as you can see, and it looks fantastic on a real Vectrex. I don't know if I keep that animation. It's just an example, and I might also not use squares but little ships or whatever. It works just out of the box. I can scroll this faster or slower. This is just a digitized joystick. I can do analog joystick movement, and in the title screen this will not be joystick controlled but by the program. But this is the idea I have, a scrolling, a fine smooth scrolling Vectorblade title which is animated, and probably if I scroll sorry, I scroll down, and if I scroll down then the kind of ships that you can encounter will appear below. Right now this is examples here. You can see still some remnants of the old tile set I used. But anyway, this is probably what's going to be the title screen. This is the first thought about it, and I did that in about, I don't know, a quarter of an hour or so. And well, I still absolutely love this smooth scrolling with clips. And you can see up here, it's right now it's 23,000 cycles for this one here, and it's still can be optimized, especially if I just use it for a title screen. This works. This is cool, in my opinion. Anyway, Vectorblade. There's not much left. I've got a more or less huge Vectorblade text. This explains many things that I did already and plan to do, and how the levels work, and how variables are set, and how I can do new bonuses, which angles I have to use in Vecchi, and all the stuff that I might at some stage forget. But if I ever want to go back to the game, I can read it here. Yeah, also the ideas for the difficulty levels. Where is it? Somewhere? I had it? Yeah, to do. Difficulty levels. Easy. Lasers go through. Laser strength equals 2. Hit points. Each enemy has hit points -1. Shots. In each level the enemies will shoot 2 shots less than normal. The attack patterns count -1, they attack less often, and attack pattern -1, this is actually a pointer to the attack patterns, and I plan to sort them by difficulty. And if I sort attack patterns by difficulty in my table, and if I do -1, then each attack is with a less difficult pattern. So the normal level is just the normal things, then and lasers do not go through, but the strength is still 2. Then hard lasers go through with a strength of 1, hit points of the enemies +1, shots +1, attack patterns count +1, they attack more often, attack patterns +1, so the easiest attack patterns are avoided. And impossible lasers goes through strength 1, hit points +3, shots. The maximum amount of shots that can be visible will be shot. Attack patterns count max is every enemy that can attack will attack. And attack pattern count actually not count the patterns +2. Only the 2 most difficult patterns will be used for attack. I think this is A, easy to program, and B, quite efficient. I think this will really make a difference in the difficulty. Okay, I'm still blabbermouthing. Vector strings, what is that? Oh, I don't know. Everything that has to do with vector strings that are printed, not raster strings, but vector strings. And yeah, I think that was about the whole source code. So this is what I was going to tell you about Vectorblade, its current stage, and how the sources are made up and what everything, well, does. I could probably go on for another 10 hours to explain everything, but, well, if you came to the end of this video, then I congratulate you. I don't know if you know anything more, but, well, good on you, and thanks. Goodbye.